All right. The purpose of this video is going to be based. This video is based on AC Systems Lesson 3. I forget actually what the name is. See, I see that real quick. Comparing direct current to alternating current. So, in this case, when we had DC, so this is where we're going to start making that transition over from just talking about DC direct current, where all my electrons are flowing in one direction. Now my current is going to flow both directions. So, really cool stuff for us nerds. But we have got our alternating current waveform. In DC, that is right about here. So that would be about the voltage we would see if that was a DC waveform. And we're going to discuss what this is called. I'll tell you right now, it's called the effective voltage, or RMS voltage. So some of you guys might have heard the term RMS. If you look at your meter at work or whatever, you'll see it's a true RMS meter. We're going to talk about that means. It's root mean square, but we'll talk about what all that stuff means live and in class. I'm not going to cover all that shit on this video because it'll be a lot longer than I planned it to be. So for those of you guys who suffered through lesson 1 and lesson 2 videos, this one's not going to be as long. There's not as much calculations on this one. A lot of the information that you're going to get, or a lot of the stuff that's on this lesson, you're probably going to find in your textbook. No, I did just want to cover a few things real quick because there are going to be there's technically 5 different types of voltage and current waves that we're going to talk about. They're going to come up a lot more into play in lessons 4, 5, or 6, but I do want to cover them now because some of the questions toward the end of this lesson, I think in the question 35 or so, starts talking about these different voltage levels that we're going to talk about on this sine wave. So on the left over here, I've kind of tried to crop it out as much as I possibly. I tried to crop the whole thing out, but you could still see the 180 no matter what I did. So I couldn't crop the whole thing out. But when we rotate, we create this sine wave, and we are going to discuss how that rotation, or how those values come about, and all the other stuff. But if you take a sine wave, it's called a sine wave for the simple fact of it's the sine value of whatever value we've got. We can see that we've got 360 degrees is a whole circle. We hopefully know that or remember that from school. But we started our initial point of 0, and then we get to 90 degrees, and then we get to 180 degrees, then to 270 degrees, and then we're back to our 360 or 0 again. And then it starts that cycle, which is called a cycle, all over again. So if we take our sine, and you guys, if you want to, if you have your calculators handy, you can do this while we're doing it. We're definitely going to be doing it in class. If you punch in on your computer or calculator, you just hit sine and then 0 equal, you will get a value of 0. Okay. If you take the sine and hit 30, you'll get 0.5. If you hit sine of 45, you'll get 0.707. If you hit sine of 90, you'll get 1. So, shits and grins, if you want, you can hit the sine of 89, you'll see it's just under 1. You can hit the sine of 91, and you'll see it's just under 1. So, what it does is it peaks at 90 degrees, and it starts going back down. As you go back down, you can plug in any value you want. It'll be proportional to the value over here. So if you hit 30 over here, you hit 150 over here, you should get the same value, because this would be plus 30 on this side, and it would be 30 away from this spot at 150. So they will be the exact same distance off of the x-axis. Then when you get to 180 degrees, it hits 0. Once you go a number over 180, any number over 180 and less than 360, you will get a negative value. And that is, again, the x-axis is going to be your degrees of rotation, and your y value is going to be the magnitude that you're going to have the sine value of. So that's, again, we're going to talk a shit ton more about that in class. But what we need to focus on, like I said before, there are 4 values that we're really going to talk about. And the 5th one I'm going to throw in because it's called instantaneous. So we'll talk about that and how we get there. The number that we come off of with the most on AC systems is the peak value. When it is at 90 degrees, it is at its maximum peak positive value. At 270 degrees, it is the value as it is at its maximum negative peak value. But everything that we're going to do is going to be based off of the peak value. And the peak value is going to be whatever the magnitude has the capability of. In this case, it's 1. So our peak value in this case is going to be 1. So I didn't draw a very straight line there. So the peak value is simply the distance between the x-axis and the very top. I think it's at 1. I don't know if it's drawn properly or not. Okay, so that's easy peasy, peak value. Then we have what is called peak to peak. That is simply the top of the top value to the bottom of the bottom value. How much distance is here? In this case, if this is positive 1 and this is negative 1, my peak to peak value would be 2. So in this case, I have a peak value of 1 and a peak to peak value of 2. Piece of cake. My peak to peak value is always going to be double peak. Okay. Now, there is something called the average voltage. The average voltage we can find by taking our peak value and multiplying it by the value of 0.637. Now, if you don't want to memorize the value of 0.637, that's fine. The way that I like to do this, I usually don't use the 0.637 value. The other way to do this is called 2 peak divided by pi. You have a pi button on your calculator. If you just take the 2 and divide it by pi and hit equal, you'll get a value that's at 0.637 value. Then you just multiply it by the peak. And then last but not least, and I'm going to tell you guys that this is going to be the most important one because this is going to be our effective value or our true RMS value. And that is going to be taking our peak voltage and multiplying it by, they say 0.707. But what I do is I take the peak value and I multiply it by the sine of 45. Because that is where my max. So basically what true RMS is when it gives you the exact same heating capabilities as a DC circuit. Okay? And we are going to talk about, there's a lot of questions in here toward the end of the lesson, like I was saying, that are going to ask you to convert peak voltage into an RMS or effective value. There's going to be take an effective value and make it a average value. In my case, you have to do a double conversion so you're not memorizing too much stuff. Okay? So that's those. Now I told you I talked briefly about a fifth one. It's called instantaneous voltage. So again, I based this one off of the sine of 45, or well, whoever created this shit came up with the sine of 45 was where my RMS value came about. But there's also what's called instantaneous voltage or current. Instantaneous voltage or current just means I pick a spot. I picked 95 degrees. I want to find out what is my voltage right there at 95 degrees. That's called instantaneous voltage. And I'm going to take my instantaneous voltage, and that is going to be equal to my peak voltage simply times the sine of whatever value I'm looking for. In this case, it'll be the sine of 95. All right, so that's how I find instantaneous. I just take the sine of whatever angle they're talking about times the peak voltage value. That's pretty much all there is to it. It's, again, this lesson, a lot of this stuff is going to be found out of the textbook. I just wanted to explain those ones to you guys. Again, if you have any questions, concerns, comments, issues, please feel free to give me a call, and let's see if I answer. Have a good one. Good luck.